Have you ever pondered why Venus, the second planet from the Sun, is hotter than Mercury, which is actually closer to our star? It's a question that baffles many, and the answer lies in a combination of factors that include the greenhouse effect and the distinct atmospheric compositions of the two planets. Let's begin with Venus and its potent greenhouse effect. Venus is enshrouded by a thick atmosphere, predominantly composed of carbon dioxide with a smattering of sulfuric acid clouds. When sunlight penetrates this heavy atmosphere, it reaches the planet's surface, which absorbs the energy and re-emits it as infrared radiation. But here's the catch. Venus's dense atmosphere acts like a one-way door, allowing sunlight in but preventing much of the infrared radiation from escaping back into space. This leads to a continuous buildup of heat, causing Venus to experience a significant temperature increase. Now let's turn our attention to Mercury. Unlike Venus, Mercury has a minimal atmosphere with trace amounts of helium and hydrogen and smaller quantities of oxygen and sodium. Due to its sparse atmosphere, Mercury lacks a substantial greenhouse effect that could help to retain heat. This results in drastic temperature swings on the planet. During its daytime, Mercury's temperatures can reach up to an impressive 430 degrees Celsius. However, at night, without an adequate atmosphere to trap the day's heat, the temperatures dive to a frigid -180 degrees Celsius. Despite being closer to the Sun, Mercury's scant atmosphere doesn't trap and retain heat as efficiently as Venus does. Venus, although farther from the Sun, experiences a more pronounced greenhouse effect due to its substantial atmosphere, resulting in higher surface temperatures. The surface conditions of the two planets also contribute to their temperature differences. Venus, with its predominantly rocky surface, has a higher capacity to absorb and retain heat, behaving much like a thermal mass. In contrast, Mercury, with its smaller size and different surface composition, doesn't retain heat as effectively. So to summarize, Venus manages to out-sizzle Mercury primarily due to its thick carbon dioxide-rich atmosphere and the resulting robust greenhouse effect. This combination traps and retains heat, leading to scorching surface temperatures that far surpass those on Mercury, despite Venus's greater distance from the Sun. It's a fascinating example of how atmospheric conditions can dramatically influence a planet's temperature, regardless of its proximity to the Sun.